Welcome to the Deep Dive. We're the show that takes complex stuff and, well, makes it make sense. Actionable sense. Today, we're really digging into a big one. Cross-account EKS deployment using the AWS CDK. Yeah, our mission here is to take all that, dense technical material, professional answers, architecture notes, troubleshooting guides, and turn it into something you can actually use. Think of it like a focused training session, just for you. We want to equip you with the core ideas for building those scalable, isolated Kubernetes setups across different AWS accounts. It's a critical skill, honestly, for DevOps, cloud engineers, anyone building serious infrastructure, or prepping for that next interview. All right, let's unpack this.
Great to be here. And yeah, this is definitely foundational. If you're building anything enterprise grade in the cloud, that multi-account strategy is, well, pretty much essential. And for containers, EKS Elastic Kubernetes Service is, often the choice. So a question you might hear, or one I'd ask in an interview for a senior role, is something like this. How do you implement cross-account EKS cluster creation with AWS CDK, including VPC peering and Transit Gateway attachment?
Right. It covers a lot of ground.
It does. So let's start with a quick summary, the elevator pitch, if you will. Basically, we pull this off using AWS CDK, which is AWS's infrastructure as code tool. We use a mix of assume role patterns for secure cross-account access, automated VPC peering for those direct network links, and transit gateway sharing using RAM Resource Access Manager. The whole point is to build these scalable, isolated EKS environments efficiently. Get rid of manual steps, keep things secure through code.
Infrastructure as code-driven automation. Makes sense.
Exactly. Now, let's break that down a bit more. Go into the why behind these choices, not just the what. First hurdle. Getting access across accounts securely. That's cross-account role assumption. CDK makes this pretty smooth using AWS's assume role. So what you do is create specific deployment roles in your target accounts where EKS will actually live. And these roles, they trust your central CI/CD account where your CDK code usually runs.
Okay, so temporary access, not permanent keys flying around.
Precisely. The big win here is security and auditability. You get temporary credentials, they expire, and every action is tied back to that assumed role. It's much cleaner, much safer than, say, cross-account IAM users with long-lived keys.
Right. Better audit trails, too.
Definitely. Now, the trade-off, or maybe a gotcha as you called it, is session duration. Assume role gives you temporary credentials, but they have a time limit.
So if your CDK deployment takes a really long time.
Exactly. It could potentially time out. That's the thing to watch. The default is usually an hour, but you might need longer for complex stacks.
So that assume role pattern really simplifies access. But that session duration limit, does that ever tempt people to, find workarounds? Less secure ones?
That's a sharp question. And yes, the temptation can be there, especially with really long, complex deployments. Hours-long pipelines, maybe?
So what's the right way to handle it?
The recommended way is never to bypass assume role for security reasons. Instead, you configure a longer session duration when you assume the role. STS lets you request up to 12 hours using the duration seconds parameter, assuming your security policies allow it. That keeps it secure, but gives you the time you need.
Got it. Extend the temporary lease. Don't create a permanent backdoor.
Exactly. Okay, so you've got access. Next up, networking. How do these isolated VPCs talk to each other? That leads us to VPC peering automation. If you need direct, private chat between two VPCs in different accounts, peering is a good option. CDK have constructs for this, like CFN VPC peering connection. You just tell it the owner ID of the other VPC.
But peering usually involves an acceptance step, right? Someone has to log in and click accept.
Usually, yes, but that's where the automation part comes in. We use CDK custom resources to handle that acceptance automatically. This is super important. It means no manual console clicking, which is slow and error-prone, especially when you have lots of accounts.
Okay, this is where it gets really interesting, especially if cloud networking is newer territory for you listening. Think of VPC peering like building a dedicated private highway. It's just between two specific office buildings, right?
Wow.
Even if they're in different cities or AWS accounts, traffic doesn't go out on the public internet. It's direct, secure, efficient, like they're neighbors.
That's a great analogy, perfect for those one-to-one links. But what if you have dozens of office buildings, building individual highways between every single pair?
Oh, yeah, that sounds like a mess. Spaghetti junction of highways.
Exactly. That's the classic n-squared peering problem. If you have NVPCs needing to talk, the number of peering connections explodes. It gets really hard to manage.
Okay, so peering is good, but doesn't scale for many accounts.
Right. And that's where Transit Gateway integration shines. TGW. For this, we use AWS Resource Access Manager, or RAM. Your central networking account creates the TGW and then uses RAM to share it with all the target accounts, the ones running EKS. Then in each target account CDK code, you create a VPC attachment to that shared TGW.
So everyone connects to the central hub instead of directly to each other.
Precisely. It acts like a central router. The trade-off is clear. TGW solves that n-squared problem. Much simpler topology, centralized routing control, fantastic for multi-account setups.
Okay, what's the gotcha with TGW then? Sounds almost too good.
The gotcha is route table management. You have to be careful configuring the TGW route tables to control who can talk to whom. Segmentation is key. Get it wrong, and traffic might go where it shouldn't, or worse, just get dropped silently. I've seen that happen, hours spent debugging because one route was missing. Details matter here.
Right. So if VPC peering is those dedicated highways between pairs of buildings, Transit Gateway is like that central transport hub, a big interchange connecting all your buildings via one main point. Makes managing traffic flow way easier than building roads between every single pair. It's about scale, yeah, and that central control. But quick question for a smaller setup, maybe just 2 or 3 accounts, is TGW overkill? Is that initial setup complexity worth it compared to just simple peering?
That is a really good point. The initial setup for TGW, with RAM sharing and the attachments, it is a bit more involved than setting up a single VPC peering connection. So for just 2, maybe 3 accounts with simple communication needs, yeah, peering might feel simpler upfront.
So it depends on the future view.
Exactly. The insight is to think ahead. If you see any real chance of growing beyond a few accounts or needing more complex routing down the line, starting with TGW often saves pain later. It builds in scalability and governance from the start. You avoid hitting that peering limit and needing a tricky migration later. Design for where you're going, not just where you are now.
Makes sense. Design for growth.
Okay, so clusters are up, networking's connected. Now, how do we control who can do things inside Kubernetes? Kubernetes access control, this is where we tie those cross-account IAM roles we assumed earlier into EKS itself. We do this by updating the AWS config map.
Ah, the magic config map that maps AWS identities to Kubernetes users.
That's the one. CDK provides helpers for this, like auth.add role mapping. Use that to grant permissions, usually system.masters for your deployment roles, to those specific cross-account role ARNs. This lets the role that deployed the cluster also manage it via kubecle.
Okay, crucial step. What's the potential pitfall here?
The big gotcha. Role ARNs must match exactly. Case sensitive, everything, get a single character wrong or the case wrong and the mapping fails silently. You'll just get access denied and scratch your head for hours.
Been there. Case sensitivity in ARNs bites everyone eventually.
It does. So that bridges AWS IAM and EKS RBAC. Now, stepping back, what about the overall structure, architectural considerations? For managing state with CDK, the usual best practice is separate CDK stacks per account. Keeps things modular, isolated, matches the multi-account philosophy.
Like one stack for the central network stuff, and then separate stacks for each EKS environment.
Exactly. Think producer-consumer. Your central networking stack produces the shared TGW ID, maybe VPC CIDR ranges. It exports these values. Then your cross-account stacks in the target accounts consume these values, importing them to configure themselves.
Nice separation. Keeps things clean.
Very clean. It helps with team autonomy, too. But the gotcha here, circular dependencies. You have to architect the dependencies carefully so stack A doesn't depend on stack B, while stack B also depends on stack A. That leads to deployment deadlocks.
Right. Need a clear dependency graph.
So let's walk through the flow conceptually, no code needed. Imagine your central networking stack in, say, account A. It creates the TGW. Then it uses RAM to share that TGW with accounts B and C. Finally, it exports the TGW ID.
Okay. TGW created and shared.
Now, in account B, your cross-account ENC stack runs. First, it imports the TGW ID from account A's stack output. It defines a VPC for EKS, creates the EKS cluster itself. Then, critically, it adds the deployment roles ARN, the one it assumed from the CI/CD account, to the AWS config map. It then creates a TGW attachment, connecting its VPC to the shared TGW. Updates its VPC route tables to point relevant traffic toward the TGW, adds node groups, maybe deploys some standard add-ons.
And the same process happens in account C.
Exactly the same pattern in account C. Each EKS stack consumes the shared network resource and sets up its own isolated cluster environment, connected via the TGW, modular, repeatable, secure.
That's a fantastic overview of how the pieces fit together programmatically. That producer-consumer model really clarifies things. Knowing that flow helps a ton. But, reality bites. Even with great design, things break. What are the common problems people hit, and how do you usually start fixing them?
Oh, absolutely. Troubleshooting is part of the game. Let's frame a quick troubleshooting framework around common observations.
Okay, hit me.
First up, identity and access issues. Big category. You deploy EKS, looks fine, but kubectl from your CI/CD account gets access denied.
The classic. What's usually the cause?
9 times out of 10, the cross-account role wasn't added to AWS config map correctly. Check that ARN again. Exact match. Case sensitive. Is the add role mapping call actually happening?
Right, check the config map contents directly in the cluster too.
Good call. Another IAM one. The assumer role call itself fails during CDK deploy. Usually means the trust relationship on the target role is wrong. It doesn't trust your CI/CD account's role. Or, less often, the session duration was too short for a long deployment.
Fix is checking the trust policy, maybe bumping up the duration.
Yep. Next category, network connectivity. You might see a VPC peering connection stuck in pending acceptance.
The automation failed.
Likely, either the custom resource that handles acceptance failed, check its logs, or the acceptor account just doesn't have the IAM permissions needed to accept peering requests from the other account.
Makes sense. What about TGW?
For TGW, you might see an attachment fail with resource not shared. This almost always means the RAM share invitation wasn't accepted in the target account, or you use the wrong TGW ARN when setting up the share or the attachment.
So check RAM, accept the share, verify RNs.
Exactly. And finally, even if everything looks connected, maybe EKS nodes can't talk across accounts.
The sneaky one. Seems like it should work, but doesn't.
Usually boils down to security groups or route tables. Did you allow traffic between the necessary subnets in your security groups? Did you update the VPC route tables to actually send traffic to the TGW? Did you check the TGW route tables to ensure routes are propagating correctly between attachments?
Lots of places for routes and rules to go wrong.
Yeah.
Need to check end to end.
You got it. Okay, so let's wrap this specific topic up with the key takeaways. If you're prepping for an interview, these are the high-level principles to remember. 1. Automation with CDK. It's not optional, really. Infrastructure as code drives consistency, speed, and eliminates manual errors.
Couldn't agree more.
2. Account isolation with connectivity. Balance security using separate accounts with seamless communication using TGW or peering. Get the best of both worlds.
Isolation, but connection. Got it.
3. Role-based security. Use assume role. Temporary auditable credentials are way better than static keys for cross-account work. Enhances security posture hugely.
Temporary credentials for the win.
4. Scalable networking. For multiple accounts, Transit Gateway is your friend. It beats the n-squared peering problem and gives you central control.
TGW for scale.
And 5. Robust access control. Integrate those cross-account roles into EKS via your AWS config map. Ties your AWS identity securely into Kubernetes RBAC.
Bridging IAM and K8s. Makes sense.
That's all for this topic. Stay tuned for the next DevOps Cloud interview question.
Wow, that was incredibly thorough. Really mapping out that whole journey, access, networking, Kubernetes integration all across accounts. You can really see how these patterns take something potentially nightmarish, managing multi-account key8s manually, and turn it into this automated, scalable, IAC-driven system. Super valuable stuff, whether you're prepping for that interview or just aiming to master cloud architecture. And maybe a final thought for you listening. Think about these ideas: isolation, shared services, automation beyond just EKS. Where else in your cloud setup could this multi-account ISC approach really simplify things and tighten up governance? Something to chew on. Thanks so much for joining us on this deep dive. Keep learning, keep building, and we'll catch you on the next one.